Those are online, Prakash and Neha. Are you able to hear me?
Yes, sir.
Yeah. Are you able to see the screen?
Yes, sir.
Okay. It's big enough, right?
Yes, sir.
Okay. Shall we proceed? எங்க இருக்கு? Yeah. So what were the concepts for which you made notes of? I told you a few concepts, right? What are the concepts? So last class till what topic did we discuss? So when I took a class on Tuesday, there was a concept that we discussed. What was it? So we did a problem also, right? Based on electrostatic potential energy. Or did I discuss about electrostatics of conductors, the 6 points? Till electrostatic shielding is what I would have told. But when I suggested, I would have asked you to go through the videos again and make a notes of it. Right? Did you all make notes? Are you all clear with it? Right? Is there any concept that is not clear? Catherine, where is you didn't upload? Again, same issue. You uploaded, huh? When did you do? Morning or late? இருக்கட்டும் பண்ணிட்டா ஓகேண்ணா பண்ணிட்டியா சரி ஓகே I'll check your சரியா இல்ல it's fine I'll finish and then check okay is that issue still existing you upload பண்ணி திருப்பி submitted because it was not reflecting okay. I'll check what that issue is எனக்கு அந்த doubt இருந்தது because you told me last time right so that is why I checked with you சரியா okay so yeah electrostatics of conductors after that there is a concept of dielectrics, right? Dielectrics and the concept of polarization, right? So what was it speaking about? I saw everybody made notes out of it, but I want to understand how much is your understanding level out of it. Pranav, can you tell me? Dielectrics have no free charges, right? So unlike conductors, what do dielectrics have inside? They have electric dipoles. And how are the dipoles initially oriented? Are they in proper alignment initially? How are they? They are randomly oriented. So when can you bring them to a proper orientation? By placing it in external electric field. When you place it in external electric field, what will happen to it? It will start experiencing torque. So due to the torque, it will start getting aligned in a particular manner, right? Then what is going to be the difference then? So when you talk about a dielectric, so you'll have the dipoles inside, right? You will have something like this, right? So like this, it keeps on going. And this is the external electric field. If I call this as E naught, then what is going to be the value of electric field inside? So this E naught will be in this direction. There will be another electric field which is exactly in the opposite direction. What is the name of that electric field? It is induced electric field. So it is exactly in the opposite direction. So had it been a conductor, what would have happened? E naught minus E induced would have been a 0. But here, since it's not a conductor, it will be a non-zero value. Then what is that non-zero value then? So E naught minus E in will be equal to, come again, E naught by kappa. So what does that kappa stand for? So it is called as dielectric constant, or what is the other name for it? Very good. It is also called as relative permeability. So what does it say? Or what does it state? So kappa will be equal to epsilon divided by epsilon naught. It is basically the ratio of the permittivity of a medium to the permittivity of free space. So this is going to be the net electric field that is present when a dielectric is there, right? So this concept led to another important concept. What is it? This led to another important concept. What is it? Okay, what is dielectric strength? So you take a dielectric and place it in some external electric field. What did she say? Strength of a dielectric. Correct, Amma. So if I take this dielectric and place it in external electric field, right? So when we talk about the strength, right, we think that it is the mechanical strength that we are talking about, means how much pressure we need to apply to break it or something like that. But that is not the case. So if you take a dielectric and place it in external electric field, what is happening inside it? There is an electric field getting induced. Though the electric field is getting induced, right, it is still exhibiting the property of an insulator. Am I clear with what I am saying? It is, see, dielectric is still an insulating a material with insulating properties. So you keep increasing the value of electric field, the amount of resistance it is going to offer is going to increase, but there will be a particular point after which it will start behaving like a conductor. So that maximum electric field that you can apply till you make a dielectric material into a conductor is what is called as dielectric strength. That is why the dielectric strength is always defined in terms of electric field. So who defines it? It's the electric field. So putting all these statements together, how did you state it? The maximum value of electric field that can be applied so that, yes. So dielectric breaks down means, please write down there. Breaks down means not literally breaking down. It should start behaving like a conductor. Okay, it should start behaving like a conductor. That is the meaning of breakdown. You will see this word in semiconductors also. Okay, so have this in your mind. So how is the dielectric strength measured in? It is generally written in terms of volt per meter. So I told you, there are two units for electric field. What are they? One is Newton per coulomb and the second is volt per meter. So it is measured in terms of volt per meter, right? So what are the next concept? What are they? Capacitors. So what are capacitors basically? So till now what we discussed is how to create charge on a material. But the question is, how are you going to store that charge? So for that, what device are you going to use? You use a device called as a capacitor. So what is a capacitor? What is a capacitor basically comprised of? It comprises of two conductors which are separated by a dielectric medium, right? So you have two conductors which are separated by a dielectric medium. So this is one and this is two, right? Now the question is, what do these conductors do? These conductors will take the charge. What does the dielectric do? What is the dielectric doing in the place of conducting medium? So why do we even need to use a dielectric? Why? Because had I put a conductor in this place, right, in the place of dielectric, then what would have happened is, whatever charges generated on the conductors would have got lost to the surroundings. Because conductors easily lose their charge to the surroundings, whereas dielectrics will hold the charge for a longer duration. So here, if you see, the main objective of a capacitor is not to conduct electricity. It is to hold the charge. There is a difference. Am I clear with what I'm saying? So what do you mean by conducting electricity? Means you want the charges to flow. If you want the charges to flow, then you would have used a conductor. But here, you don't want the charges to flow. You want the charges to stay, right? At the same time, they should stay for a longer duration. So who can hold it for a longer duration? Obviously, a dielectric. That is the reason why the previous topic was dielectric. Okay, and that point of E naught divided by K is very important. Right. Now the next question is, when you talk about the shapes of the conductors, right, depending on the shapes of the conductor and the dielectric medium that is used, capacitors can be classified into many types, among which three of them are parallel plate, spherical, and cylindrical. So when you talk about a parallel plate capacitor, basically you have two parallel plates like this, right? You have two parallel plates like this, which is where a dielectric medium is sandwiched between, right? So you give positive charge here and negative charge here. Am I clear with this? Right. So due to this, what will happen is there will be an electric field which is generated from the positive towards the negative plate. What is the value of that electric field? Sigma by 2 epsilon naught due to one plate. So this will generate another sigma by 2 epsilon naught. Both are in the same direction, so they add up to give you a value of sigma by epsilon naught. I hope that concept is registered, right? So what is the net value of electric field? It is going to be sigma divided by epsilon naught. First point to be noted, right? Now, for this material, first thing that I'm able to observe is, see, logically, if this material has to get charged, you need an external source to charge it. So what is the source you'll use? You'll use a normal battery, right? So when you do it, you can say that the charge that is getting stored on the material, can I say it is directly proportional to the amount of potential difference that we apply? Am I right? So when you remove this is already there in your notes. So when you remove the proportionality symbol, what do you get? You will get Q is equal to C into V, where C stands for capacitance. So this is the property of the capacitor. So it is going to be capacitance. Am I right? So what is going to be the value of C then? C will be equal to Q divided by V. So how is C measured in? What is the unit used for C? Farad. So how did you get that farad? It is actually coulomb per volt. So this coulomb per volt is called as farad. It is derived from the name of the scientist Michael Faraday, right? So it is F-A-R-A-D. Since it's the name of a scientist, you use capital F. But capital F is a very big unit. That is why if you see, all the capacitors will generally have their capacitance in terms of microfarad. Am I clear with that? Right. So now this capacitance is equal to charge divided by potential difference. So this point alone I will reteach so that you can use the same logic to derive the capacitance for any kind of a shape. So basically what is capacitance? It is the ratio of the charge by potential, or you can say the amount of charge stored per unit potential. Okay. If you say that, there are two things I need to use. In the place of Q, I'll use sigma into A, where A is going to be the cross-sectional area of this plate. Am I right? So it is going to be sigma into A. 1 minute. So C is equal to Q divided by V. So C will be equal to Q is sigma into A divided by. How can I write potential difference in terms of electric field? We have a relation. I told you it is very, very important. We did a problem also based on it. What is the name of it? It's called some gradient. It's called potential gradient. Never forget it. Right. So E is equal to minus dV divided by dr. So since here the electric field is uniform, this minus sign has a significance. What is it? The electric field is always from the higher to the lower potential. Electric field is always from higher to the lower potential. So we are not using minus because we already know the direction. What is the value of, so instead of dV, what I'll do is, I'll use V divided by, if I take the distance of separation between the plates to be small d, then electric field will be equal to V divided by small d. So this E goes to the other side, V will be equal to E into V. So in the place of V, can I write it as E into D? So this is going to be sigma into A divided by E is going to be sigma by epsilon naught multiplied with D. So sigma and sigma will get cancelled. This will go to the numerator. You will get epsilon naught into A divided by D. Am I clear with this? So this is how you derive everything. So it's only 3 steps. Okay. So whenever you are asked to calculate the capacitance for any kind of a device, the first thing is you need to write the definition of capacitance. What is the definition of capacitance? C is equal to Q divided by V. Right. Write Q in terms of whatever surface density it is speaking about. Mostly it will be surface charge density only. Sorry, whatever charge density it's speaking about, mostly it will be surface charge density. If it is the case, you write it as sigma into A. And potential, you'll write it in terms of electric field and distance. So it will be E into D. So take those values, substitute, you will get the final expression. So from here, there is an important point that we can conclude. What is it? Capacitance does not depend on the charge or the potential difference. Rather, it depends on the geometrical parameters like area of cross section, the distance of separation between the plates, and the permittivity of the free space. Am I clear? So this is how it works. So it is going to be epsilon naught into A divided by D. Now the next question is, right? Now the next question is, what if a dielectric is inserted? That also is there. No, you will have this expression epsilon naught A divided by D minus T plus T by K. You have that, no? So how did we get that? I'll show you the derivation also. I'll show it quickly. So let's say the distance of separation between the plates is D. Let the thickness of the glass slab be, okay, the thickness of the dielectric slab be T. Okay, then how much is this distance going to be? Obviously D minus T. So for dielectric slab, I'm just shading it. Okay. Now here, what is going to be the value of electric field? Inside a dielectric slab, we saw what was the value of electric field. It was not E naught. It was E naught by K. So here the electric field is E naught by K. What is the value of electric field here? It is air medium. So it is only going to be E naught. Am I clear with this? So here you have positive sign, here negative sign. So there is an electric field in this direction. When this electric field is generated due to the capacitor, inside this dielectric, how much is the electric field existing? E naught by K. How much is electric field existing here? It is E naught. Is this point clear to everyone? Okay. So what does the definition tell you? C is equal to Q divided by V. I told you need to start with it. What is the value of Q? Sigma into A divided by, here when I talk about the potential difference between these two plates, it is the potential difference developed across the dielectric plus the potential difference that is developed across the air medium. So can I write it as V1 plus V2? Am I clear with this? So this is going to be sigma into A divided by, how will you write V in terms of E? How will you write V in terms of E? You will write it as E into D. So V1 I can write it as E1 into D. So what is the value of E1 here? E naught by K multiplied with how much is the electric field acting for? It is acting for a thickness T. T plus E naught divided by, how much is E naught acting for? D minus T. So D minus T. But don't forget that E naught is still, which one? What happened? In which one? I wrote there. Oh, sorry, into. I'm sorry. This one, no? E naught into D minus T. Sorry. Yeah. So it is sigma into A divided by E naught by K into T plus E naught into D minus T. But what is the value of E naught? E naught is still, that value you already know. So what is the value of electric field generated between the plates of a capacitor? It's sigma by epsilon naught. See, if you remember, right, the previous chapter, I think 24th problem of your textbook was based on the same concept. It is sigma by epsilon. That logic is what we are using it here. So how much is the value? So don't forget this value. I want you all to be careful. Electric field due to one plate is how much? Sigma by 2 epsilon naught. So electric field due to both the plates are in the same direction. So those sigma by 2 epsilon naught get added twice. So you get sigma by epsilon naught. That value is substituted here. So it is going to be sigma into A divided by, how much is that going to be? Sigma divided by K times epsilon naught into T plus sigma divided by epsilon naught into D minus T. Now what will get cancelled? You can take out sigma common. So you will have sigma into A divided by D minus, so 1 by sigma by epsilon naught itself, I can take out common. Into what is that you're left out with? I'm just reversing and writing it. You will be left out with D minus T from here plus T by K from here. So sigma and sigma get cancelled. So what is that you're left out with? It will be epsilon naught A divided by D minus T plus T divided by K. Am I clear with this? I think you would have written it already. Right. So we can save the time of writing. Is this clear? Now I have questions from this. So if K is the dielectric constant of some dielectric, what will be the dielectric constant of a conductor? It's not zero. It's infinite. It's not defined. For a conductor, you cannot define dielectric constant. It will be infinite. Okay. So for a conductor, K will be equal to infinity. If you substitute it there, what will you get? See, 1 minute. I'll just take cases so that you will understand it better. 1 minute. Don't write it. I'll just go one by one. See, what is the expression we got? C is equal to epsilon naught A divided by D minus T plus T by K. And you have to remember the situation. How is the situation? So there was, listen. There was a dielectric of thickness K, and this part was, of thickness T, and the remaining part was D minus T, right? So if you keep this as the general expression, the first point to be observed is, right? The first point to be observed is, if the space is completely filled with dielectric, what will happen? So if the space is completely filled with dielectric, what would have happened? See, if this T becomes a complete space, then how much will this distance be? It is D. No, see, the distance of separation between the plates is D. What I'm saying is, I'm completely replacing the air medium with dielectric medium. Those who are online are able to see. Yes, sir. One minute. Yeah, now I hope you're able to see, no? Is the cursor there? So if it is completely filled with dielectric, then what will be the relation between T and D? This slide, no? So D will be equal to T. If you take this and substitute it here, what will you get? So I'll call it as C dash, for instance. You will get epsilon naught A divided by this, and this will get cancelled. So what will you get? D by K. So this K will go to the numerator. You will have K times epsilon naught A divided by D. What is this value? So this is the capacitance you had when the capacitor was completely filled with. It was complete. What did you see? Dielectric. This value, epsilon naught A divided by D. You look at the permittivity, you can tell. So this was the capacitance when the medium between the plates was air. So if at all somebody gives you the value of capacitance when the dielectric is completely filled with air, and they ask you how much is the change that will occur when you insert a dielectric, then how many times will it get multiplied? We get multiplied K times. So answer will be K times C naught, where C naught is the initial capacitance. You can make a note of this point. Done. So this word is important when it is completely filled with dielectric. Okay. Now, if it was filled with multiple dielectrics of dielectric constant K1, K2, so on till Kn, and thickness T1, T2, so on till Tn. So you can observe the pattern there. If it is filled with multiple dielectrics, right, then what will be the value of capacitance? Sorry. So C dash will be equal to epsilon naught A divided by T1 minus T2 minus T3, so on till you will have plus. You look at the pattern, no? D minus T. So D is common. So wherever you have this T1, T2, T3 everywhere, you will have a minus sign. Wherever you have T1 by K1, T2 by K2, there you will have plus sign. Right? Is that how I wrote it there? So I would have written it as D minus T1 plus T1 by K1 minus T2 plus T2 by K2. Is that how it is written? Where did I write? Okay. So C dash is equal to epsilon naught A divided by D minus of, I wrote it like this. So your last one is Tn, right? So you'll have Tn here plus T1 by K1 plus T2 by K2 plus so on till what will be the last term? Tn divided by Kn. So this is how it is going to work. Clear with this? Next. What is the other point that we saw? Isn't capacitance cinema? Okay, capacitors in series and parallel, right? Shall we proceed? So done with this? Yeah. So what will you get for capacitors in series? What will be the equivalent capacitance? So for capacitors in series, first of all, when will you say that the capacitors are in series? What is common between them? The charge remains constant throughout, right? So C equivalent will be equal to, sorry, 1 by C equivalent will be equal to 1 by C1 plus 1 by C2 plus so on till 1 by Cn. See, whatever you get for resistor, you will exactly get the reverse here. Similarly, for capacitors in parallel, what will you get? So C equivalent will be equal to C1 plus C2 plus so on till Cn. Okay. Now, this is all about capacitors in series and parallel. Now, what we'll do is we'll do some problems from your textbook. So open your textbook. In NCERT, right? Go to Go to page 77. Go to page 77. Look at example 2.8. So in page 77, look at example 2.8. So read the question. So what is the question? Read it. Can someone read it loud? Vaishnavi, can you? Yeah. So when you look at the diagram, right, there is a capacitor. For this capacitor, you have a dielectric slab whose dielectric constant is K. What is the thickness of it? So it is occupying 3/4 of the total space. Right, next. So where D is the separation of the plates. Okay. Okay. So here one important point to be noted is the dielectric slab and this conductor has the same of the same something cross-sectional area. So when they have the same cross-sectional area, you can use that formula which I gave. Okay. So what will happen? C dash will be equal to epsilon naught A divided by D minus T plus T by K. So it is going to be epsilon naught A divided by D minus, what is the value of T? 3D by 4 plus 3D by 4K. So D minus D by 4 is, sorry, D minus 3D by 4 is D by 4 plus 3D by 4K. So what can I take out common? So I can take out the D by 4 common. So epsilon naught A divided by, if I take the D by 4 outside, it is going to be, or can I take D by 4K itself constant? So if I take D by 4K constant, so how much should I compensate here? I should compensate with a K plus 3D. So this will go to the numerator. So what would be the answer? 4K into epsilon naught A divided by D into, oh, D is taken out now. It will be K plus 3. Okay. So what is this epsilon naught A divided by D? Just now I told you. It is C naught. So what will be the answer? 4K times C naught divided by K plus 3. So this is the answer that would have been given. Check the answer. Right. So whatever they did is a part of the derivation which I explained. Here we directly use the formula, no? So what they did is they use the derivation part. Okay. So make a note of it.
Sir? Sir, you're not audible, sir.
Okay, sorry. Now,
Yes, sir.
okay. Would you understand what I did?
No, sir.
Okay. 1 minute. My mic was off. Okay, see this problem, there are four capacitors which are of equal capacitance, which are connected in this kind of a format, where I'm saying C1, C2, and C3 are in series, right? C1, C2, and C3 are in series. So I found the equivalent capacitance by applying this formula. 1 by C equivalent is equal to 1 by C1 plus 1 by C2 plus 1 by C3. C1, C2, and C3 are same. So I wrote it as 3 divided by C. Okay. So this is 1 by C equivalent. So what will be the value of C equivalent? It will be C divided by 3. But what is the value of C? It is 10. So listen to this. If I replace C1, C2, C3, I can replace it with a 10 by 3 microfarad capacitor. This 10 by 3 microfarad is connected across this 10 in parallel. So how to check that is observe. So you see the positive terminal is connected to this junction, right? So if I take this point to be A, if I take this point to be B, listen to this. Listen. So if there are 2 points which are connected with a wire, I repeat, if there are 2 points which are connected with a wire where there is no resistor or capacitor between them, then those 2 points are said to be at the same potential. Meaning the potential of point A and the potential of point B is the same. Similarly, if I take this to be C and if I take this to be D, for instance, then the potential of point C and potential of point D are the same. Meaning, this is at a potential VA, this is at a potential VC. So this point is at a potential VA, this is at a potential VC. Similarly, this point is at a potential VB and this point is at a potential VD. So what is the potential difference between them? Here it is VA minus VC. Here it is VB minus VD. They both will also be same. And how much will they be same to? They will be equal to 500 volt. Why is it so? Because if you look at the bottom point, if I take this to be D and if I take this to be if I take this to be E and if I take this to be F, for instance, then A and E are also connected using a wire. C and F are also connected using a wire. So they both are also at same potential. C and F are also at same potential. The potential difference is how much? 500. So the same 500 will appear across the 10 by 3. If at all there was any capacitor above that, there also it will be the same. Whereas in this diagram, it will not be 500. In the sense, here it is 500, okay. But across AD, it would have been 500. But between AB, CD put together, it is 500. So across AB, we don't know what is the potential difference. Across BC, we don't know what is the potential difference. Across CD also, we don't know what is the potential difference. Am I clear with this point? So now we are able to understand the difference between these two diagrams, right? Now, 10 by 3 and 10 are connected in parallel. So what will be the equivalent capacitance? CP will be equal to 10 by 3 plus 10. It is going to be 40 by 3 microfarad. That's it. So the equivalent capacitance is 40 divided by 3 microfarad. That is the first part of the question. I hope it is clear, right? So those who are online, is it clear? If there is any point which is not clear, please let me know. Those who are online, is it clear?
Yes, sir.
Okay. Clear with this point? Okay. Now see. What is the next part of the question? They're asking, find the charge on each capacitor. So we have 4 capacitors here. We need to find the charge across each. So the formula for charge is Q is equal to CV. So this is the formula we are going to use. So we know the capacitance of each, but what is that we don't know. We don't know what is the potential across each capacitor. So you know the potential drop across only one capacitor. What is it? You know it across C4. So what is the potential drop across C4? So if I take Q4, it is a charge across the 4th capacitor. So it is a capacitance of 4th into the potential drop across 4th. So what is going to be the answer? C4 is 10 into 500. So it is going to be 5000 microcoulomb, or it will be 5 millicoulomb. Both are same. So it will be 5000 microcoulomb. Okay. Now, the challenge is, if you look at the initial diagram, right, you will not be able to solve this because it is difficult for us to find what is the potential drop across each. See, in this case, it is easy. Can you tell me how much will it be? It will be 500 by 3. Why? Because all are identical. You're able to understand. See, 500 is across AD. 500 is going to lie across AB, BC, and CD put together. Okay. So whenever the capacitors are in series, just go to the derivation once and see how did we derive the capacitance in series. What is the logic we used? So the definition says the charge across each capacitor is same, but what will happen to the potential difference? They get divided. What did we do to them? With that step only, you would have acquired the equivalent potential, equivalent capacitors. What did we do? So you wrote V1 plus V2 plus V3. No. So what will happen here is the potential difference across the capacitor C1 is V1, across C2 is V2, and C3 is V3. V1 plus V2 plus V3 put together should be how much? It should be 500 because the same 500 is appearing across the combination. So if they are of equal capacitance, what will be the potential drop across each? That's what I told. 500 divided by 3. You're able to understand? So that is one way of solving. Or else what you can do is, whenever you're asked to solve these kind of problems, you look for the capacitors which are in series. So for that, find the equivalent capacitance, like how we did in this problem. What are the equivalent capacitance you found? It came out to be 10 by 3, right? So take the 10 by 3 and multiply it with that 500. Because you know what is the potential drop across this equivalent capacitance. How much is it? How much is the potential drop between BD? It is 500. I told you the logic of why it is 500, right? So what will be the charge present on this 10 by 3? So charge present on 10 by 3 will be capacitance multiplied with potential difference. So how much is it going to be? It will be 5000 divided by 3 microcoulomb. You do the reverse process of what I told and see. So here, how much is the capacitor? How much is the potential drop across C1? If you take it individually, how much is the potential drop? Here it is 500 by 3. Multiply and see. 500 by 3 into 10. Is it not 5000 by 3? So here it is 5000 by 3. Here it will be 5000 by 3. Here also it is 5000 by 3. So if you do it individually, you will get 5000 by 3 on each capacitor. If you find the equivalent value and then do it, the final answer you are getting, no, that is the answer for all the 3. Both are same. So what is the procedure we need to follow? Wherever you have series combination, first find the equivalent capacitance. Second is try to calculate the potential drop across it. So multiply the equivalent capacitance with the potential drop. So equivalent capacitance with the potential drop, that will give you the charge. So that charge is the individual charge present on each capacitor that has participated in getting this 10 by 3. So how many capacitors put together is 10 by 3? 3. So you should not make this mistake of writing the answer as 5000 by 3 by 3. Don't do that. This 5000 by 3 is there everywhere. One of the common mistakes is they write 5000 by 9. Am I clear with this point? So don't do that mistake. Okay. So answer is 5000 divided by 3 microcoulomb. Would you understand? Give me your book. Yeah. So I'll tell you some problems. You can try them the next class before the next class. That is 2.5. See page number 86. Page number 86 in exercise problems. You can try out 2.5, 2.6, 2.7 also you can do. 2.8. Yeah. You try these problems alone tomorrow's before tomorrow's class. We'll solve them. And I'll give you more problems based on this kind of equivalent capacitance. 2 point additional exercise. 2.2. See that one is there. I'll solve that in the class because we have to redraw the circuit. I'll teach you. See, these are all simple problems. You can just do it in 10 minutes. So that's why I asked you to try. Okay. Try them and come. This energy stored in a capacitor derivation part is actually not there, but I'm sure you would have written it. Right. It will save you at any point. No worries about it. Okay. So derivation part is actually not a part of your syllabus. So you need to know the values alone. What is the value? Half CV square, Q square by 2C, half into QV, right? So the end result is needed. And there is a last concept, which is energy density. So what did you get the energy density as? You would have got half epsilon naught E square. Is that there? Yeah. So you would have seen how you got that value also. You would have written half CV square divided by. So what is energy density? Energy per unit volume. So half CV square divided by volume. Then you would have derived half epsilon naught E square. This value is to be remembered because in magnetism, whenever we discuss, we'll see what is the energy density in magnetism. That will come out as half B square by mu naught. Okay, at that point, it will help you. And we'll solve some problems based on that. And there is one more concept which is not a part of your textbook. That also I'll explain tomorrow. Okay, with that, this chapter will be over. And I'll try to do more of problems. Okay, because exercise problems are very easy. I'll give you an assignment. Based on that, I'll solve the problems. Okay. So do you want me to discuss paper 1? The first paper, the first test paper. You got your marks, sir? Answer didn't match, sir. It didn't match with answer here. But you didn't get marks, sir. Okay, அது எடுத்துட்டு வா. Okay. யார் comes? Which one are you saying? I'm asking about the first test. அதான் வரல அந்த PDFs வர மாட்டேங்குது. I have to solve that issue. Got it corrected? You didn't send it later, no? I'll check. Okay. I'll see you guys tomorrow.